Hi everyone, myself Varsha Sivan from the Department of Physics. Today we are going to discuss about an important topic in electrostatic, that is Coulomb's law, or it is called as Coulomb's inverse square law. Coulomb's law is an experimental law in physics which quantifies the quantity of force between two stationary charges. The force between two charges at rest is known as electrostatic force or simply Coulomb's force. And according to the Coulomb's law, there are two charges are there. Suppose we have one charge Q1 and the another charge Q2. If they are separated by a distance of r, then according to Coulomb's law, the magnitude of force between these two charges Q1 and Q2 is directly proportional to the product of their charges. That is, F is directly proportional to Q1 into Q2. And the law again states that the force between these two charges is inversely proportional to the square of the distance between them. That is, F is directly proportional to 1 upon r square. And in altogether we can write it as F proportional to Q1 Q2 by r square. And we can change the proportionality into a equation by a constant, that is proportionality constant, which is F is equal to K Q1 Q2 by r square, where K is called proportionality constant, and the value of K changes with respect to the medium. Suppose if these two charges are placed in a vacuum or a free space, then the value of K will be 9 into 10 raised to 9. And from this equation we can find the unit of the K, that is F ka unit, force ka unit Newton, or R will be in meter. So it will be Newton meter square by charge ka unit Coulomb, 1 Coulomb, 2 Coulomb, Coulomb square. So the unit of K will be Newton meter square upon Coulomb square. So the value of K will be 9 into 10 raised to 9 only if the two charges are placed in air or vacuum. Okay. So if value of K, if these two charges are placed in a dielectric medium, then the value of K will be changed, and the value of K can be represented by K is equal to 1 by 4 pi epsilon 0 for free space. In dielectric medium, the epsilon is changed, in epsilon 0 is changed into epsilon, where epsilon is called permittivity of medium, permittivity of space, and epsilon 0 is called permittivity of free space. So if the two charges are placed in a dielectric medium, then epsilon 0 changed into epsilon r, where the relation between epsilon 0 and epsilon r is epsilon is equal to epsilon 0 into epsilon r, where epsilon r is called relative permittivity of the space. So the Coulomb's law states the charges relation between the electrostatic force and their charges. That is, by the definition we can define Coulomb's law as the electrostatic force between two charges Q1 and Q2 is directly proportional to the product of their charges, and it is inversely proportional to the square of distance between them. Okay. So it will Coulomb's law only gives the magnitude of force. Now we can discuss about the direction of force by the another form, that is vector form of Coulomb's law. we discussed the magnitude of electrostatic force. So, next we are going to find the direction, because we already know the force has two, force is a vector quantity. So, it has direction and magnitude. So, next we are going to check the direction of Coulomb's force or electrostatic force. So, that is Coulomb's law in vector form. Just like we did in the last section, we have two charges q1 and q2, which is separated by a distance r. So, if these two charges are positive, then we know that for like charges, that is if it is a positive charge and positive charge, then like charges are repel each other, and for a unlike charges, that is for positive and negative charge, they are attract each other. So, suppose I take here as two positive charges plus q1 and plus q2, then for the first charge q1 there will be a repulsion due to the second charge q2. So, the force will be in this direction, that is the force on the charge first charge q1 due to the second charge q2. So, it will be force on first charge due to second, the direction will be in this direction. Okay. So, just like that, what about here? Here there is charge 2, and due to charge 2, there will, due to first charge, there will be a force on second charge. It will be the force on second charge due to first charge. Okay. It will be again a repulsive, since I take two positive charges. And what about the direction or direction of position vector? Let us see. For the position vector of from first charge to second charge, it will be in this direction. It can be represented by r21, or the position vector from the second charge to first charge, it will have the direction here. It can be represented by r12. Okay. So, these two forces, there are two forces are there and they are equal but in opposite direction. So, we can write it as F12, the force due to first charge, force on first charge due to second charge, that will be equal to F21, but they are in opposite direction. So, I put a negative sign here. So, let's write the first charge F force F12. F12 according to Coulomb's law, it will be equal to K into product of their charges Q1 into Q2 and inversely proportional to the square of distance between them. So, I write it as magnitude of R square. And now, let us see the direction of force. The direction will be in the position direction. So, R21 unit vector. So, R21 unit vector means the unit vector of position vector R21. So, what will be the second force? Force on to second charge due to first charge, that is F21, which will be equal to K into the product of their charges Q1 into Q2 divided by R square, square of distance between them, into the unit vector of second position vector, that is R12. Okay. So, these are the vector form of forces, Coulomb's forces, that is F12 and F21. So, from this equation we can write that F12 we can rearrange it as F21 is equal to K into Q1 Q2 by R square. Here R12 and R21 are equal but in opposite direction. So, it can be written as R21 itself with a negative sign. So, from this we get that F12 is equal to minus of F21. Okay, so this is the basic equation for Coulomb's force. Okay, so the objective of Coulomb's law is it will predict the electrostatic force between any two stationary charges knowing the quantity of charges and their distance. And also it helps to solve the unknown quantities of force, charges and the position in a physics solved problems. Okay. So this is the basic concept of Coulomb's law. I rewind once again, that is the Coulomb's law mainly state about the force between any two point charges which is in stationary, and according to law it is directly proportional to the product of their charges, and the force is inversely proportional to the square of the distance between them. So we can write force is equal to magnitude of Coulomb's force or electrostatic force is equal to K into Q1 Q2 by R square, where K is for a free space, K can be written as 1 by 4 pi epsilon 0, where epsilon 0 is permittivity of free space. It have the value 8.85 into 10 raised to minus 12 Coulomb square by Newton meter square. Okay. So, by knowing the quantities of charges and their distance, we can easily find the electrostatic force between them or Coulomb's force between those charges.